Government documents admit flat earth. Now, I had to leave a lot out this morning, so understand that this is just the tip of the iceberg. But just so everyone knows, those watching, listening, just so everyone knows, I've spent a lot of time digging into this, reading the actual documents, going to the actual CIA website, the Army website, the Navy website, the U.S. Air Force, many NASA documents, Russian documents from Russia that we stole from them during the Cold War. Amazing things that I'm discovering here. This document right here, as most of you will note, where did it come from? Up top there. The Central Intelligence Agency. Declassified document that we stole from the Russians from 1948. What's that? I wanted you to see that. Scientific Measurements of the Earth, June 1948. It was originally in the Russian language. This is the translated thing. Date distributed, July 1949. Number of pages 19. Just so you can see, here's getting into it here. Now, notice it says, the paper says, outer gravitational field and shape of the physical surface of the Earth. Gives this guy's name, some Russian guy. Center Science Research, Institute for Geodetics, Aerial Surveying and Cartography, Moscow. Everybody see that? All right. You can go through this entire document if you want to. I'm just pulling out something that I found very interesting in 1948 from Russian scientists that was classified. They stated here that where it is not determinable at all of the points of space without the knowledge of the shape of the Earth, but since the shape of the Earth is not known. I'm not going to read all this, because if I read all this today, we'd be here for a long time. In fact, I cut out stuff. I just wanted you to see that a Russian scientific paper that was classified in 1948 states the shape of the Earth is not known. Now, let me remind you that we are always told, oh, we've known the shape of the Earth since 300 BC. How did Russian scientists, and let me just say that Russian scientists are not stupid people. In fact, reading through their documents, they seem to be more honest with themselves than a lot of American scientists. Because the Russians were just trying to figure out they were trying to figure out all truth so they could gain any kind of advantage over us militarily. All right? Just wanted you to see that, 1948. Here's another document. We move forward in time a little bit, 1956, 57 time period. Now what happened, let me say, what happened between about 1948 and this time? The development of jet aircraft and the increase in rocket technology. So we were beginning to be able to fly a little higher, a little faster. So you would think, okay, they know, right? So the Russians started this study, I found out, in the 1940s. They began to study the light within, they said, the firmament. All right? This is their words. The light, but they were doing a light study because they were trying, again, they were trying to figure out how they could manipulate or use this knowledge against us with optics and all kinds of stuff. So you see this is released by, approved for release, 2000, relation between light scattering coefficient for various angles of optical thickness of the atmosphere. Here we go. You can tell when they're older documents. Atmospheric refraction errors for optical instrumentation. Fun reading, folks, I'm telling you, fun reading. There you have it. Tells you technical memorandum, blah, 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 same thing, preliminary report, October 1953. White Sands Proving Ground, La Cruces, New Mexico. This document was not to be seen. This document contains information affecting the national defense of the United States within the meaning of the espionage laws, Title 18 U.S.C., Sections 793 and 794. Its transmission or the revelation of its contents in any manner to an unauthorized person is prohibited by law. So this was classified in the 1950s. He's talking about basic equations for atmospheric refraction and all this stuff. He says, here, now I want to point this out. Present equations hold for any altitude. Everybody see that? I don't have time to read all of it. Present equations hold for any altitude. All right, let's see what they're talking about. Table of contents, introduction, validity of flat earth assumption for atmospheric calculations. Validity. You know what validity means? Something that is a solid fact. And this is the introduction. This is the table of contents, introduction, the validity of flat earth assumption for atmospheric calculations. If it wasn't flat, if the earth was not flat, why would you start off a classified, under threat of law in the Espionage Act, why would you classify that? Introduction here says a comprehensive study of atmospheric refraction errors for optical instrumentation. What is it based on? Based on a flat earth assumption, will be published subsequently. The relative mass of the atmosphere at any elevation angle is given approximately by the cosine of the elevation angle. I may be pronouncing some of this wrong, but listen, this relationship is correct for a flat earth and a flat atmosphere. This relationship is correct for a flat earth and a flat atmosphere. And they're going to publish these results. I just want validity of flat earth assumption. Validity. They're not saying, okay, see what some of them, this is what some of them say, that the flat earth assumption is just to simplify things. But what this is saying is this so-called flat earth assumption is valid. It's valid. Do you see it? Zoom in on it a little bit just so you see it. Validity of flat earth assumption. Just so you know, the definition of validity. The quality of being logically or factually sound. Right? Look at that.
The state of being legally or officially binding. Meaning this could stand in court.
Yeah. Oh, wow. That's a good point there, Nathan. He said the second part of the definition, the state of being legally or officially binding or acceptable, that this would stand up in court. Here's more of it here. Calculation of light dispersion, higher orders. This is USR, geophysics, light dispersion. This is the study they were doing. Proved presented light dispersion, higher orders can be computed from data obtained in plain direct observation for USSR references. And this is the institution, the Academy of Sciences, USSR Astrophysical Institute. I mean, again, we're not fooling around here with dummies, right? And this paper, they go on, and again, they go on to tell you the study of the dispersion of light in the Earth's atmosphere, degree, doctoral, physics, math, science, and so they just tell you the whole thing here. Joint Council, March 1957, Academy of Science, USSR. Again, a lot of this I just pulled out just so you would see that these documents are real and what they were about. But let's get to the interesting stuff. Here's all these PhDs and scientists that are involved in this study at this time. Tells you a little more of the introduction, the table of contents. In investigation of light scattering in the Earth's atmosphere, formula for the brightness of the blue sky with consideration of first order scattering and all that, you know, blah, blah, blah. All right. And talks about this first semester, 1957, dissertation, blah, 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 goes through that. Let's get to the interesting meat of this here. Tells you the instruments they use. So right here, it said the observations were carried out in 12 locations at various altitudes above the sea, various climate, meteorological, synoptic conditions. The observations were carried out mainly during high transparency of the atmosphere and the visual range of the spectrum, in the absence of snow cover. In the investigations, 2 instruments designed by VG Fescanoff or whatever were used. One of these was a visual photometer of the daytime sky intended for measuring the brightness of the firmament. They were wanting to study this, and they said also the other photoelectric halo photometer for determining the brightness from near sun halo. Whoa. Pause. Time out. Time out. How is something that's supposed to be 93 million miles away, could anything about it be called near? The near sun. Okay? But it gets better. He says that to study the near sun halo and also the sun on the surface perpendicular to these rays. The dissertation contains a certain formula of the brightness of the sky, taking into consideration only the brightness of the first order, derived on the assumption of a flat earth and giving some conclusions. Because remember, they're trying to study how light is operating within the atmosphere with a near sun halo, and they tell you over flat earth. This is a Russian document, 1957. It was classified. This is a secret eyes only, Central Intelligence Agency declassified 2006, January 16th, 1958. This was a memorandum for the record. This was a meeting. They were talking about things going on in Russia. But this document makes this statement at the end. The shape of the firmament. Do you see that? Whoa. Hold up now. Wow. I think only certain solid things have shape, right? The shape of the firmament. Does everybody see that? You see that? What is a classified document? Classified by the United States government, talking about the shape of the firmament. I can tell them what the shape of it is. Right? But they're talking about this. How does an atmosphere, invisible vapor, how does it have a shape? I mean, you know, when the vapor gas, you know, I'm boiling water, or my wife's making tea, and I don't see any shape to the vapor. But they're talking about, we got to figure out the shape of the firmament. Just like one of the Russian documents talked about, they were measuring the brightness of the firmament. They used that term, the brightness of the firmament over a flat earth. The Russians were talking about this back then. All right? Now let's keep going. Y'all going to love this. This is, what's the website? Everybody look at the top there. All right, NASA.gov, April 1961, National Aeronautics and Space Administration, calculation of wind compensation for launching unguided rockets. Pretty serious stuff, rocket science. Rocket science, calculating wind, right? Pretty important thing to know when you're shooting rockets. Just so you see it up close, calculation of wind compensation for launching unguided rockets. So we're talking about rockets by Robert L. James Jr. and Ronald J. Harris, Langley Research Center, Langley, Virginia, Langley Field. I would say pretty important stuff, right? All right, technical note, here we go. Summary, method for calculating wind compensation for unguided missiles. It is derived from which has a greater degree of flexibility than previously proposed methods, blah, 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 and they get into it. So they're telling you, summary, here's what we're up to, trying to figure out how to guide rockets. Let's look at this. It says trajectory simulation incorporating the above requirements is presented in reference 8. In addition to the above requirements, this simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry and roll, and the missile position, again, space will deal with that. They don't even, it's not what they're talking about. What we think, what they've told us, and what they know space is, two different things. So when they say it, they don't mean what they've lied about. The missile position in space is computed relative to a flat, non-rotating Earth. April 1961, NASA technical document for calculating unguided missiles, not anything we're sending into space. Just unguided missiles, like the V-2 was an unguided missile. Let's keep going here. Here's another one. Okay, completely different document. Where did it come from? NASA.gov, right? Unpublished preliminary data, atmospheric oscillations, tells you the people. Georgia Tech project. Under contract, Georgia Tech project contract, prepared National Aeronautics and Space Administration. So this was in conjunction with their engineers. Engineering Experiment Station, Georgia Institute of Technology, Atlanta, Georgia. The requirements for additional copies. Talks about that, says the Department of Defense contractors must be established for DDC services or have their need to know certified by the cognizant military agency. So this was not to be passed around. This was need to know. All right. Georgia Tech project, just so you see it. Boom, boom, April 1965. Tells you the abstract, develop present theories of atmospheric oscillations. Blah, blah, blah. I don't have to. All right. A model frequently used is that of, everybody say it, flat, non-rotating Earth. The most one can profitably simplify the problem is to consider the isothermal atmosphere, plane level surfaces, and a non-rotating Earth.
That's it, man. They say flat Earth more than we do.
They say flat Earth more than we do. Now remember, I have shown you documents here, and again, there's so much more. I'm having to trim this down. We're already at 12:15. All right, so I'm trying to get through this, and there's just so much here. But I just wanted you to see. We're talking about 1948, 1957, 1960s, 1970s. Here, everybody see this? NASA technical memorandum. Where'd it come from? NASA.gov, right? Declassified. Freedom of Information Act tells you all about it. Determination of angles of attack and side slip from radar data and the roll stabilized platform. Langley Research Center. What's in Langley? Virginia? Yeah, CIA headquarters, exactly. Also the National Aeronautics and Space Administration, Washington, D.C. Wait a minute, I thought they were in Florida and Houston, Texas. Oh, that's right. I'm sure they have an office. All right, let's keep going here. Here's the abstract. NASA Langley Research Center, technical memorandum, blah, blah, blah. Here is in the abstract. Basically what they're describing this manual is all about. It's a summary of it. Here's what they say. Equations for angles of attack and side slip relative to both rolling and non-rolling body axis system are derived for a flight vehicle for which radar and gyroscope attitude data are available. The method is limited, however, to application where a flat, non-rotating Earth may be assumed. The application for this whole thing has to be based on a flat, non-rotating Earth. Wait a minute, how many documents are we into here? I'm going to read that again. Equations for angles of attack, side slip relative to both rolling and non-rolling body axis system are derived for a flight vehicle. So we're talking about stuff that flies. And for which radar and gyroscope attitude data are available. The method is limited, however, to application where a flat, non-rotating Earth may be seen. To say that the method is limited to a flat, non-rotating Earth means it does not work for a spherical Earth. Let's keep going. Here we have something else. Is that the same one? I got the same. It's the same manual. So I think, yeah, here we go. Let's keep going here. Yes. This is interesting because he talks about, it gives you this little frame reference. Look at north, south, east, west, right? And they're telling you that, again, that represents the Earth fixed axis system. Everybody see that, right there? The radar provides range, azimuth, and elevation data from radar site to the vehicle throughout flight. So we're talking about stuff happening throughout flight, right? The data in conjunction with wind data can be easily converted to pitch, blah, 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 flight path angles. It is assumed herein that the Earth is represented as a flat and non-rotating reference frame. Why would it be assumed that the Earth is represented as a flat, non-rotating reference frame? Exactly. I'm going to tell you, I'm blown away. But this Earth fixed system is interesting here. Why do I say Earth fixed? Isn't it supposed to be spinning, tilted, orbiting, flying through the universe? Yet the stars never change in the sky, right? The night sky. But yet we're spinning, flying, orbiting. Millions of miles. Been doing it for thousands of years. Nothing in the night sky ever changes. They know. Come on, they know. It is assumed herein that the earth is represented as a flat, non-rotating reference frame. Yet they're going to tell us snipers have to adjust for shooting a 1,000-yard shot that takes about 2 seconds. Maybe less than that. But you don't have to calculate the Earth's spin for an aircraft, for a helicopter, a drone.
Right.
The space shuttle, I'll show you that in a minute too.
I brought the drone too.
Let's keep going. Here it is. Notice it says, also by definition, the X and Z plane will be vertical, perpendicular to the horizontal plane of the Earth at all times. The horizontal plane of the Earth at all times. What's this one? This is NASA Technical Memorandum, NASA.gov, mathematical model of a CH-53 helicopter. You guys know a helicopter pilot, right? So here's the NASA manual on that. Ames Research Center, Moffett Field, California. Equations of motion. The helicopter equations of motion are given in body axes with respect to a flat, non-rotating Earth. Meaning the helicopter takes off, it doesn't have to worry about the Earth spinning below it.
You can't stay in one spot and wait on China.
That's right. Can't stay in one spot and wait on China. I love it. Exactly. Now, I'm going to go back to one. This is the first government document. I shared this at the Flat Earth International Conference in Raleigh in my presentation, 2017, last November, that Robbie Davidson put on. I thought this was something to find this document. All right? This is, how little did I know. This was the tip of the iceberg. But this is a NASA technical manual. You can look it up. Anybody out there watching and listening this morning, you can Google NASA document 1207. You can pull up, it'll take you straight to nasa.gov. You can pull up the PDF. You can read this for yourself. This is free information. Right? This is what NASA says. The derivation and definition of a linear aircraft model. In the introduction, they flat out say right here, this report documents the derivation, which means the origin, and the definition of linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. Everybody see that? Derivation means the origin. Definition means this is how it's defined. This is how it works. So they're talking about the equations, and you want to talk about the calculus and trig this thing gets into. The equations are based on these airplanes flying over a non-rotating flat Earth. Question, why would this be in any technical manual of anybody if it doesn't exist? I mean, think about it. They claim the Coriolis effect, that snipers have to calculate the spinning of the Earth, the Coriolis effect, when they're shooting at, a 1,000-yard shot or something. Yet they don't have to for Mach 1, 2, 3, 4 aircraft. You don't have to calculate the spin. No. This is just about, these planes fly over non-rotating flat Earth. So, well, Pastor Dean, this is what I heard. Oh, well, they're just doing that to simplify the equations. Oh, really? I'm sorry. I didn't know that NASA rocket scientists and MIT mathematicians couldn't factor in 8 inches per mile squared. I'm sorry, they have to simplify the math. Maybe they missed a class at MIT or something. I don't know. But this is crazy. Now, you can try to dismiss this if you want to, but it's also in the conclusion, the concluding remarks of the report and all the math and the equations. Look at that. This report derives and defines a set linearized system matrices for rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. I didn't write that. It seems that someone at NASA is a flat earther. Oh my God. Right? How can this be? No, they have to design stuff for it to work the way things are. That's why. Let's keep going here. There's your definition of derivation. Obtaining or developing something from a source of origin. Why would you develop the equations for aircraft to fly over something that doesn't exist? Oh, let's factor in the unicorn equation. Just in case, the Pegasus, the flying horse equation. So, yeah. No, they're telling you it exists. Definition, of course, is a statement of the exact meaning of something. Here's some of my detractors. They talk about the said documents quoted are quote mined and cherry-picked by fraudulent and deceptive flatheads. One example, NASA official document 1207 admits flat Earth. The sad fact is that they don't bother or are too ignorant to read and understand. And what's interesting about this, and of course he goes, these models are widely used not only for computer applications but also for quick approximations and desk calculations, leaving out Earth curvature and rotation for simplification. So again, I covered that. They're going to claim that it's to simplify their math and equations and their work. So they do it real quick on the desk, but I looked up approximation, and an approximation means not really correct, right? So anyway, they write a lot of stuff that's not really correct, but I wanted to address the issue of cherry picking. Of course, the same thing said here pretty much, and let's just deal with this. I actually had to put this on Facebook because it really illustrates the point. Well, here we have an orange tree with cherries on it. Okay, first of all, that doesn't exist in nature unless it's some kind of genetic manipulated thing in a lab somewhere. But this doesn't really exist. I said, some people have accused me of cherry picking through the government documents that state their equations are based on a flat, non-rotating Earth. But should there be any flat Earth cherries to pick on a globe Earth orange tree? Should there at all? But they tell me that the cherries are on the orange tree to simplify the orange tree math. Thus, I should ignore the cherries. I just wanted to illustrate that, of course. And there's your globe Earth tree with flat Earth cherries on it to pick. Okay? And really, if it's not flat, why address that? And some of them tried to say, well, okay, it was because of just for short distances. Well, I don't see the shuttle landing over short distances. Even the true thing it's used for, which I'm going to address this morning. I don't see Mach 1, 2, 3, and Mach 4 aircraft like the SR-71. I don't see it being short distances that it covers in very, very short amount of time. All right? So what I'm getting at is that excuse really falls flat. And as I said last week, and I'm going to stand firm on this, the reason that so many different government documents, technical manuals, MIT, different universities, Georgia Tech we addressed, use these flat Earth equations is because it is flat. All right? And they know it, and they've known it for a long time, and they have to design things to work as reality is. Okay? And here was the one that kind of started. This is the title of one of the manuals. Everybody read this with me. Propagation of electromagnetic fields over flat Earth. Army Manual, February 2001. You can say, oh, Pastor Dean, the 1950s stuff and the 1960s stuff, oh, they just didn't know. They've learned stuff since. Right? Nope. They tell you right here. And you go into the manual. Here's the table of context. It says comparison of principal fields from an ideal dipole oriented perpendicular to a horizontal and homogeneous flat Earth. Army manual. They tell you right here, it's assumed that the transmitting antenna and target or receiver are located above but near the surface of a flat idealized Earth. Over and over again. Army Research Laboratory. This is another one, calculating low atmosphere profiles, sound speed at night. So calculating sound speed, right? Pretty important stuff. It says to briefly examine short-range acoustic attenuation at night, we use low atmosphere profiles of wind speed, temperature, relative humidity shown before as input to a flat earth non-turbulent acoustic propagation model called the Windows version scanning fast field program. So, you know what they tell us? That the atmosphere is not moving with the spin of the earth. It's non-turbulent. I mean, it's not carrying anything with it. Here's MIT, Massachusetts Institute of Technology, the top technical school in the country. Or at least one of the top. I'm sure they argue among themselves who's the top. What's this? dspace.mit.edu. Right? Property-based system design method with application to targeting system for small unmanned vehicles. So this is a targeting system developed Massachusetts Institute of Technology, blah, blah, blah. Tells you who it is, the author of this. And then in the description, it says 3 targeting methods were considered assuming a flat earth. Whoa, 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 whoa. Why would an MIT professor, PhD, why would he assume the earth is flat? Assuming a flat earth. No, he says 3 targeting methods. Consider assuming a flat earth using DTED data and using angle range data. The evaluation, I hit it myself. The evaluation revealed a descending utility order, flat earth, and range based upon the system's requirements. I mean, these and aeronautics and astronautics. Here. Flat earth assumption, mind-blowing. Just wanted you to see MIT and other doctoral candidates and PhDs saying it's flat and it's not moving. That's what the Bible said. It's flat and it's not moving.
We can say it, but you say it, you're crazy.
Yeah, if I say it, I'm crazy. But these guys can say it, and their papers get passed around among the elite, and a lot of them classified. Yes, and many of them do have Nobel Prize, and they get sometimes they get classified, right? And then declassified. Here's one. This one is NASA.gov. Now, this is general equations of motion for a damaged asymmetric aircraft. So what they're trying to do is fix equations if a plane loses part of its wing or tail fin or whatever, how to compensate and all that stuff, right? So that's what this is about. And the technical manual gives you this stuff. The introduction. Here's the introduction, right? Just so you know, it says, in order to analyze the dynamics of damaged aircraft, the dynamic equations of motion must properly reflect the underlying physics. Now, I want to say that again. I want everybody to pay close attention. They're telling you right here in the introduction of this, and they're showing you a damaged aircraft. They're saying, in order to analyze the dynamics of damaged aircraft and dynamic equations of motion must properly reflect the underlying physics. It must, what we're going to do here must reflect the true physics.
Must be true reality.
Physics. People say, you don't understand physics. Okay, well, these people do. All right. Who are we talking about here? The American Institute of Aeronautics and Astronautics. And here's what they say. Rigid body equations of motion, reference to an arbitrary fixed point on the body. There are several approaches that can be used to develop the general equations of motion. The one selected here starts with Newton's laws applied to the collection of particles defining the rigid body. Any number of dynamics or physics books can serve as references. So they're saying the physics books can serve as references. So in this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed. Why? Why? So you're telling me that the physics of a non-rotating flat Earth are the proper physics in a NASA document. This is not Pastor Dean saying this. These are NASA documents. These are government documents. Does everybody see that?
And they're not the same authors.
No. No. Over many years, different schools, the University of Delaware, Georgia Tech, MIT. No. Russian scientists. Now, here's a doctoral dissertation by a PhD candidate that became part of this European Control Conference. In fact, I guess he graduated, but this doctoral dissertation that he began to speak to, I guess, the European Space Agency or whatever, a new path planner based on flatness approach, application to an atmosphere reentry mission. This was designed for the space shuttle, quote, reentry. And it's funny, they put orbit and reentry and stuff like that into quotations. And I'll explain all that next week. We'll get into that next week. But notice the outline of his doctoral dissertation, statement of guidance problem. Why would you have a guidance problem? Well, if you're basing stuff on a spherical Earth and it's really flat, then you're going to have a guidance problem. Right? So this guy comes along and goes, you know what? We got to get back to a flatness approach. I'm not making this up. Right? Flatness-based trajectory planning. Here we go. He's talking about for this little vehicle right here. And we'll keep going. Notice he says model in flat Earth coordinates. Everybody see that? Again, this doesn't exist, right? Flat Earth doesn't exist, but we're going to have a model for it and all this unicorn math. Sprinkled with fairy dust. So this guy's doing a doctoral dissertation in this present time to help with guidance system of the shuttle, and now we have unmanned shuttle system. But he's doing this and saying, we've had guidance problems, so we got to go to a flatness approach, to a flat Earth model. Now, I'm going to tell you, this guy's way smarter than me. I couldn't do this kind of math, not even in my dreams. Okay? But he does. And he says, guys, we need a flat Earth model. And here's the math for it. Shall we keep going? Notice this. Assumptions, meaning things we assume are true. Flat Earth. Coriolis and centrifugal forces neglected.
Don't matter.
Here's a doctoral candidate who graduated, got his PhD, becomes a speaker to the European Control Council, and he's telling them it's a flat Earth. We ignore Coriolis, meaning the spin of the Earth. It's completely ignored. Why? Because it doesn't exist. And it's what the Bible said all along. The earth is fixed, stable, immovable, still, and at rest. Everything secret is being uncovered. Oh, payloads for spinning projectiles. Army. Think you need to know where artillery is going to land? Look here. Projectile flight dynamics. A 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. The assumption of these equations assume a flat Earth. These equations, a whole bunch of math we're going to do. BG Karpov experimental observations of dynamic behavior of liquid-filled shells. U.S. Army Ballistics Research Laboratory, Aberdeen Proving Ground, Maryland, August 1961 is a reference to this. But he says, and again, a projectile, you want to know where that artillery round is going to land. And what this study is, the one that has a solid explosive versus one that has a liquid payload. They're talking about chemical weapons or biological weapons. So they want to know figure out the equations. So a 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. Again, why would you do unicorn math? Why would you do Thor hammer math if they don't exist? Why would you try to calculate ballistic missiles, unguided rockets, shuttle landings? Why would you base all your equations, all of your science on a flat Earth, non-rotating, non-moving, stationary atmosphere if it doesn't exist no more than a unicorn or Thor's hammer? This is the Army Research Laboratory. Notice every time when you see .mil, whenever you see .mil, the only people that can have .mil, military. This is the Army's Research Laboratory. Beacon position and altitude navigation aided by magnetometer. I'm not going to try to pronounce those people's names. You can see the document prepared by the University of Delaware, Department of Electrical and Computer Engineering, under contract to the U.S. government. I guess these people are dummies, right? They're stupid, right? This tells you who they are. I'm not going to get into all that, but this tells you the PhDs and the people who were assisting this study. And here we find something. Problem formulation, coordinate systems. The motion of an object usually described by rigid body equations of motion derived from Newton's laws. This section summarizes and notates 3 kinds of coordinate systems. The first is the Earth-fixed coordinate system, which is fixed to the Earth with a flat Earth assumption. Okay, now remember, we're talking about beacons for aircraft, and aircraft flying, moving, and we're talking about stuff that's moving. Why would you assume, first of all, why would you use the term Earth-fixed? I'll deal with that in a second. And a flat Earth assumption. An assumption means something that is just known to be true. It's just assumed because it is known. It gets more interesting because they have a little diagram here of what they're talking about. And this little diagram of the Earth seems to look like something. And they tell you that this y-axis and the x-axis are horizontal. Oh, like that. Horizontal. And that this little disc right here is flat. And it even has a nice little dome over it. And fixed points on the dome that they use for navigation. This is not me. I want to repeat, Army Research Laboratory, .army.mil, not Pastor Dean. And look, does this not look like something maybe we've seen? Oh, what is that? Let me back up. Do you see that? But we're the crazy ones. Why is the biblical Hebrew cosmology shape of the earth in a U.S. Army manual? Why? Oh, Pastor Dean, that's just a coincidence. Oh, really? Well, let's keep going. Look at that. They know the truth. Here we go. This is a different one. Everybody see where this came from? NASA.gov. You could interchange CIA.gov, NASA.gov. It's all the same. Okay? They work together. In fact, I believe that all high-level NASA people are spooks, is what I believe. All right? Here we have the singular arc time optimal climb trajectory of aircraft in a two-dimensional wind field. Oh, Lord. These guys, right? NASA research, smart people, are rocket scientists. Everybody said, I'm not a rocket scientist. Well, these are, right? All right? So this document goes on to say, in our minimum time to climb problem, the aircraft is modeled as a point mass, and the flight trajectory is strictly confined in a vertical plane on a non-rotating flat Earth. Do you see that? Does everybody see that? And then they've got this nice little equation here. Thus, the pertinent equations of motion for the problem are defined in the state variable form as, and then they give you the math. Wait a minute, is this unicorn math? Is this Thor hammer math? Wait a minute, no, it's flat, whoa, what, non-rotating flat earth math. Oh, I'm sorry. Could we just substitute Pegasus, unicorns? No, exactly. Let's keep going. Here's another one. Closed form solution for ballistic vehicle motion. Ballistic vehicle motion. A closed form solution is developed for the motion of a ballistic vehicle entering the atmosphere over a flat, non-rotating Earth. Frank J. Barbera, Cayman Sciences Corporation, Colorado Springs, Colorado. Closed form solution for ballistic vehicle motion. Meaning we got to know where this thing's going to come down. And what does it say right here? Entering the atmosphere over a non-rotating flat Earth. Let's end this. Here's another one. Vision-based mobile target geolocalization and target discrimination using Bayes detection theory. Oh, it's a mouthful, right? This is a more modern, I can't remember the year on this one, but anyway, you see this is the Academy Center for the United States Air Force, U.S. Air Force Academy, UAS Research, and this is for targeting for unmanned vehicle, aerial vehicles targeting manual. Yes?
And if anyone wants to reach out to the gentleman who wrote the paper, their emails are listed right there.
Oh yeah, this one does have his email on it.
All of them, there's a string of them. Check them out.
Here we go, check it out here. The objective of geolocalization problem is to estimate range to target, which can be estimated using the flat earth model shown in figure 2. Now, let me explain something to you. I played a little golf in my day, right? And I know that I hit a 9-iron 160 yards on a normal day. So if the ground is level, I know if I hit my 9-iron the correct way, it's going to fly in a nice little arc, and it's going to land about 160 yards right on the green and roll right up to the hole. Right? I've actually made an eagle that way one time. All right? So I know. So if the ground is 20 yards higher, say the green is 20 yards higher from where I'm standing, so you change the altitude. The ball is not going to fly in the air as long, so it's not going to go as far. So if it's a little higher, I have to go to an 8-iron. Back it up, so because I'm going to hit an 8-iron or even a 7-iron, so the ball will get there. It's the opposite. If it's lower by, say, 20 yards, then I usually have to back up a couple of clubs and maybe hit a pitching wedge. So it changes where where my ball's going to land, the target. I'm shooting at that pin, at that green. But I know just the slight changes in elevation are going to change the distance that my ball will travel. And I've hit enough balls with those clubs to know how far they're going to go if I hit them right. Huh?
And it's not going to land in Georgia.
So we're talking about here unmanned aerial vehicles targeting objects. Stuff that's moving in the air and on the ground. And what do they say? It says the objective of geolocalization problem is to estimate range to target, which can be estimated using the flat earth model shown in figure 2, which would be this little thing right here. No curve. Do you notice? The flat earth model. And your little aerial craft locating a target. Now, if this line was curved here, as it does, 8 inches per mile square, that line is going to intersect at a different point. I'm not a geometry teacher, but that I know. Maybe it's just from golf, right? Flat earth model range estimation using flat earth assumption. Unmanned vehicle targeting manual from ResearchGate, but of course we showed you, United States Air Force Academy. Does everybody see that?